19, what can we actually do? Can we solve these problems? So the science focus on page 511 is a good one to read because it talks a little bit about the politics of climate change. And a lot of the things we've talked about haven't had a lot of political slant to them, but this one can. Interesting to note that 2017, the EPA chief, Scott Pruitt, he does doubt the link between carbon dioxide levels and climate change. He does not want to identify carbon dioxide as an air pollutant, and many people call him a climate change denier, and he's the head of the EPA. So it's just interesting to think about. There was a 2017 Gallup poll, and it showed an increased concern regarding climate change. There was a low point in terms of how concerned people were in climate change in 2011, kind of increasing throughout the first decade of the 21st century, and then it hit this low, or increase and then decrease, but it's going back up. So I think that's a good thing. I like the bathtub model, which they talk about in 512. So read that. It does a good job of kind of explaining how naturally carbon dioxide levels in the atmosphere would stay the same, and where the carbon dioxide goes, but why is it increasing now? And then page 513, figure 1916, excellent summary. Make sure you can explain how each method would actually slow climate change. So if we cut fossil fuel use, okay, how is that going to slow climate change? You have to be able to explain that. So these would be your identifies. Another great science focus with carbon sequestration, which is something we'll look more into, but is it possible that we can actually capture all the carbon dioxide either before it's released or somehow from the atmosphere and store it somewhere, maybe where it originally came from, like from fossil fuels. So if we have a coal bed that we've extracted all the coal, can we somehow get it down there, but it has to stay? The government can certainly do a lot of things to help to regulate our emissions of carbon dioxide and methane, for example. Doing a carbon or an energy tax. New taxes are never popular. Cap and trade policies, like what was used for sulfur dioxide emissions. Shifting subsidies, right, to lower the cost of things to more low carbon sources. And then a lot of people feel that developed countries, such as the United States, should help the least developed countries and developing countries shift their technology so they don't have to follow our path. And then, of course, slowing population growth will decrease energy demands, etc., which could help to slow climate change. 2015, we had the Paris Agreement or the Paris Accord. Basically what this said is that each country kind of develops and reports on their own plans to help mitigate climate change with some certain goals in place. There is no punishment if a country doesn't meet their kind of quota, if you will. 2017, President Trump said that the United States was going to pull out of the Paris Accord, which wouldn't actually be able to happen until 2020. So we'll see what happens there. And we do have some cap and trade programs locally. There's the Northeast Regional Greenhouse Gas Initiative, which Massachusetts is part of. So there are some in other parts of the country as well, in the EU. So there are, there are international efforts, there are federal efforts, there are statewide efforts, regional efforts, local, towns, cities, even individuals doing things, which brings us to page 519. What can you do to reduce your carbon footprint? So read through these and think about how would each of these changes actually reduce carbon dioxide emissions. And then, of course, we can always plan for, well, what if it all goes to hell anyway? What can we do? All right, and then 19.4, okay, is about ozone depletion. So this is kind of our other big global air issue. So what happens with ozone depletion up in the stratosphere? That's where our ozone is concentrated. Is there CFCs, chlorofluorocarbons. When those rise up into the atmosphere, okay, up into the stratosphere, when they react with ultraviolet radiation, a chlorine atom kind of gets kicked off. So we have a free chlorine atom. That chlorine can then react with an ozone molecule, and you get ClO and then diatomic oxygen. Cool, fine, broke down ozone molecule, but it gets worse. Then that ClO and a free oxygen, that if that free oxygen could, it would bind with the diatomic oxygen to form ozone, but it has a really stronger attraction to the ClO molecule, and then you get the free chlorine atom and another diatomic oxygen, and then we're right back to where we started with that free chlorine atom. So one chlorine atom could break down lots and lots and lots of ozone molecules. Okay. Rowland and Molina, the two scientists who are very closely associated with ozone depletion and their findings, they did a lot of work, and in the 80s, 70s and 80s, they kind of said, hey, look what we found. CFCs, they're persistent. They don't break down. And it takes 11 to 20 years for them to reach the stratosphere. So CFCs that were emitted when you were born are just reaching the stratosphere now. And then they said, so CFCs, it's I said ODS on these, ozone depleting substance. What they do is they break down ozone, and then they said that each CFC molecule or each ozone depleting substance can last for a really long time, like 65 years or so. So Rowland and Molina, good scientists know, they came out with this report. They had all this evidence, and then people said, wow, why do we care about the ozone layer? It's not just sunburns. Okay, that's a super important one. That's why you wear your sunscreen so you don't get sunburn. But we have other effects as well. One of the most important ecological effects is that if you have an increase in ultraviolet radiation from ozone depletion, you'll have reduced phytoplankton populations. And remember that phytoplankton is by far the largest contributor to net primary productivity of the open ocean, or gross primary productivity and net. So we have this big problem. What do we do about it? 1987, Montreal Protocol. International agreement. They cut emissions of CFCs, and it worked. So awesome. Just goes to show that when everyone accepts the data and agrees on it and comes up with a solution, we can solve problems. Slightly new problem. Some of the substitutes that have been used for CFCs are also ozone depleting substances or greenhouse gases. So we'll have to keep working on that one. And that's pretty much the end of chapter 19.